Hey there, Anatomy Super Friends. It's Dr. Blake Martin here, and I'm talking to my advanced kinesiology students about how you calculate the resistance arm in the lever system of the body. And in this case, we're going to talk particularly about the human arm. So, as you recall, the human skeletal and muscular system uses typically third-class levers in order to do its glorious movement things. And so, for example, in the case of the elbow, you would have the fulcrum would rotate about the center of the joint. Sometimes we call that the axis. And then the force is generated upward by this muscle contracting and becoming shorter. And then the resistance arm runs from the axis all the way out the arm. Typically, the resistance is the center of mass of the resistance arm. In the case of your arm, that would be somewhere probably along here, where the center of mass would be relative to everything. And but that changes whether or not you're holding on to something heavy. And the really fascinating thing is the way that the length of the resistance arm changes depending on its angle. So, for example, if I was standing and I have my arm here, well, let's change the center of mass of the resistance arm by picking up something heavy. I've got my backpack. It's not hugely heavy, but it's heavy enough. And so if I stand here and I have this straight up and down, we're going to put the fulcrum, or the axis, right in line with this green string. Then the center of mass, oh man, that fell and it was terrible. I'm going to use it anyways, I don't care, I got to get this done. Ow, I poked myself with a pin, that was awful. I hate that. So if we take my arm at 90 degrees, my forearm, then there's the fulcrum, and there's the center of mass of the resistance arm. And you can see that the line is, we would measure the resistance arm between those two lines, like that. If, however, I had my arm much lower, at this angle, I need to move this line over to show the true length of the resistance arm. And we can see by these holes that I'm putting in this wall at a scholarly institution whose name shall not be mentioned, that it's a shorter resistance arm. In the same way, if I hold my arm up like this, we also have a similarly shorter resistance arm. The greater resistance arm is when my arm is at 90 degrees in this instance. And typically it's greatest when it's along the horizon in a gravitational environment. So, to measure the resistance arm, we start at the fulcrum. We go to whatever the angle of the arm is, the center of mass of the resistance arm, and we measure between those two vertical lines, and that's how we get our resistance arm. And that's all about I have to say about that.